I'm just going to go ahead and get rid of the right-hand support force as far as torques are concerned by putting my origin right there. Everybody okay? That means the torque produced by the weight of the plank and the torque produced by the weight of the man have to be equal, yes, and opposite. They have to add to 0. Everybody good? So that's exactly what I'm doing right here. I'm adding up my torques around my origin. Now, I didn't bother with showing which direction was positive or negative, but I also pointed out over there how I got around that. I'm going to point it out over here again. The distance from my origin to where the weight of the plank is being applied is 0.8 meters. But it's to the left. So I'm going to put it down as a negative. The weight of the plank is 300 newtons, a lot more than the weight of our plank. Okay? Plus x, that's the distance from the origin to where the man is standing, right? Times the weight of the man, and I put in negative 400 newtons because it acts down. If you just keep track of your directions, your up, down, right, and left as positives and negatives, then the direction of the torque will take care of itself. Every time. Okay? All right? So that having been said, I've rewritten it as a ratio. Look, the ratio of our forces is 3 to 4. Therefore, the ratio of the distances is also 3 to 4. Everybody good? The man weighs 4/3 as much as the plank, so he will be 3/4. Note what I did. The man weighs 4/3 as much as the plank, 400 to 300, so he will be 3/4 as far from the origin as the plank. Ratios are your friend. And no, I didn't work it out. I figured 3/4 of 0.8. How are we doing? Patrick, how are we doing? We're doing okay. Patrick says we're doing fine. Okay. Stephanie, how are we doing? Is Patrick great? Okay. Danny, how are we doing? You got a question? All right. 5 hours of sleep isn't enough. Okay. Not enough. You're going to start to hallucinate. So fun. All right. So finally we have this thing. And this is like the pole that you hang a sign from on the side of the building, right? Okay? We've got the pole sticking straight out, and so that when you hang the sign from it, it doesn't just rip the pole out of the wall. You've got this cable that goes from the end of the pole up to the wall as well, right? Everybody okay so far? Right now, happily, there's no sign on this. But a couple of things to point out. The length of the pole here is 2 meters, and the distance from the hinge where the pole is located up to where the cable ties in is 3 meters. So the ratio of those distances, the horizontal distance, the vertical distance, is 2 to 3, right? Everybody okay? You say that again. Ratios are your friend. The ratio of the horizontal distance to the vertical distance is 2 to 3. That means the ratio of the vertical component of, let me back up. The ratio of the horizontal component of the tension to the vertical component of the tension is 2 to 3. Ratios are your friend. Everybody okay? Any questions about that? That's going to come in handy. Okay? The pole or the plank is uniform. What did I just say? The weight's in the middle. And I just use 10 for my gravitational acceleration because it's not going to matter. It cancels out anyway. Okay? So I said, hey, the weight of the pole is 58 newtons. Put that in the middle. Okay? 1 meter from the hinge and 1 meter from the tension. I don't know the force from the hinge on this end, either the vertical or the horizontal component. I don't know the tension on this end. I cannot add up my horizontal or vertical forces and get an answer yet because both equations will have 2 unknowns. Dang it. So, put my origin at one of them, and that gets rid of the torque produced by that force. So I'm going to put my origin right here at this end, at the left-hand end. Okay? I'm going to set my torques equal to 0. There won't be a torque from the hinge because it's at the origin. So here we go. Adding up my torques, distance to the center of the pole times the weight of the pole, plus distance to the tension times, what's with this? What does this represent? T subscript y. And why would I do that? Take a minute, talk with your people about why. What this represents, T subscript y, and why I chose that particular value. So,
That's what I'm thinking.
these are torques. Okay, who does not know what that T subscript y stands for and why I chose to use that value only? Okay, Lanre, what do you think? What does the T subscript y stand for? There we go, it's the vertical component of the tension. Why, Lanre, am I only using the vertical component of the tension? Colin.
So the vertical components are independent?
This is true, but that's not why. Brandon.
I'm thinking one of two things. Either A, the tension of the horizontal component somehow, like, I don't know, just like doesn't matter, or like it's non-existent, cancels out.
Doesn't matter, this is true. Why doesn't it matter?
Because it cancels out. Because you don't like it. I don't know.
Richard.
Isn't it because the origin is on the pole, so then if you try to find the horizontal component, you would have to use the cosine of 0, which is 0. So then
There we go, now we're getting somewhere. Okay, so there are two ways you can look at this. One is, realize if you look at the horizontal component of the tension, it goes right through the origin, doesn't it?
Mm-hmm.
So the perpendicular distance to the horizontal component is 0. The other way to look at it is this reminder, torque is a cross product. Only the component of the force, which is perpendicular to the torque arm, R, actually causes a torque. Remember me with the wrench up here,
Oh, yeah,
pushing
it's-
straight into the handle? What happened?
Nothing happens.
Yeah, nothing. That did not produce a torque. The horizontal component here is just taking that meter, taking that pole,
Horizontal.
and here's what it's doing. You ready? The horizontal component is taking that pole and pushing it this way.
That's not tension.
That tension doesn't cause any change, any rotation. The vertical component, however, causes it to rotate. So that's why I'm only using the vertical component, because only the part of the force which is perpendicular to the torque arm causes a torque. How are we doing? Pretty good? Where are we at here? Right here? Here's okay. So if we get below horizontal, then I'm worried. Okay. So, finishing this up. You know what? Only the vertical components hold up the weight, right? And the weight is halfway between the two ends. So guess how much the vertical component here holds up of the weight? Half. And over here the vertical component holds up the other half. There we go. So we get our 29 newtons there. We already said the ratio of the tensions was 2 to 3. I'm not figuring that out for you. You do that. Everybody okay? And once you've got both the horizontal and vertical components of the tensions, you can find the total tension. It's just the Pythagorean theorem. Colin.
Is the origin in the middle or the far left?
The origin is the far left, right here. Okay?
Just in general, whenever we're trying to find torque, would you recommend setting the origin on one of the forces? That way we can easily just make it 0
Every time.
every time.
Unless there's only one thing that you don't know, in which case you're happy already anyway, right? But if there's two things that you don't know, like, particularly 4 and 6, yeah, put the origin where one of the forces that you don't know is at, and then the torque from that force goes away. And haha, I don't care about you. Shoot. Okay? Alright, all of that having been said, we've already said, hey, the vertical force from the hinge has to be the other half of the weight, right? Okay? The horizontal force from the hinge has to be the same as the horizontal force from the tension, because they're the only two horizontal forces. We got that. And once you know both the horizontal and vertical forces from the hinge, you can find the total and the angle. And no, I'm not doing those things for you. How we doing?
A little sore.
Just a little?
Yeah.
Yes. He had swim practice this morning.
Kim, was that
I'll make the swimmers come do my leg workout with me sometime.
Never.
Uh,
Bad. Can I get extra credit?
You should have seen it.
I'll do it if you can walk in it.
Bad. I'll do it. I'll do it.
Careful, Andre.
Do Mr. Lion's leg workout? I'll do it.
Mr. Lines is a speed skate.
I was like happy. I was like,
Okay, alright, so we are done with these. What are you working on now?
Analysis.
Analysis, get it done. Note there will be a quiz on this material next time. You might want to take photos of it. It will not be exactly one of these problems.
Okay. Here, I'll post the.
It'll be a problem, no.
I'm gonna go take the